Students, in this video we will discuss general methods for the preparation of alkynes. Right students, first of all we will see how can we prepare alkyne by dehydrohalogenation of vicinal dihalides. Students, here we used two terms. The first one is dehydrohalogenation. We must know what is the meaning of dehydrohalogenation. Dehydro means removal of hydrogen and dehalo means removal of halogen. So what is the meaning of dehydrohalogenation? Dehydrohalogenation means removal of hydrogen along with halogen. Removal of hydrogen along with halogen from adjacent carbon atoms. Right students? Now the second term which we used here is vicinal dihalides. Students, we must know what are vicinal dihalides. These are the dihalides which contains two halogen atoms on adjacent carbon atoms. The dihalides which contains two halogen atoms on adjacent carbon atoms are known as vicinal dihalide. For example, we will write some examples to understand what are vicinal dihalides. For example, we have CH2, CH2, Cl, Cl. This molecule is vicinal dihalide because here two chlorine atoms are present on adjacent carbon atoms. I hope vicinal dihalide is clear to you students. Now students, we will see how can we prepare alkynes by the dehydrohalogenation of vicinal dihalide. We will see the example of preparation of ethyne. For example, if we have a molecule like 1,2-dichloroethane, CH2, CH2. This molecule is vicinal dihalide because it contains two halogen atoms on adjacent carbon atoms. When this molecule is treated with alcoholic solution of potassium hydroxide, elimination of two molecules of hydrogen halides takes place from adjacent carbon atoms, and after the removal of two molecules of hydrogen halides, a triple covalent bond is formed between two carbon atoms. Now students, this reaction occurs in two steps. Now we will see what are the two steps. In the first step, we will see here, this is the first step of the reaction, right students, and here we will see when this vicinal dihalide is treated with alcoholic solution of potassium hydroxide. It means we dissolve potassium hydroxide in alcohol. Now we will see what product is formed after this reaction. Hydrogen and halogen, they will remove from adjacent carbon atoms. So after the reaction, here we get Cl double bond CH2. Right students? Hydrogen is removed from this carbon and one hydrogen is removed from this carbon atom. So as a result, we get a double bond between carbon number 1 and carbon number 2. Clear students? Now students, we will see the next step of the reaction. We will write HC, Cl double bond CH2. Right students? So in the next step, again we will use alcoholic solution of potassium hydroxide. That means we dissolve potassium hydroxide in alcohol. What will happen? Hydrogen and halogen atoms removed from adjacent carbon atoms. So after the reaction, we will get a triple covalent bond between two carbon atoms. We get this product, that is ethyne. Right students? Beside this, we will also get potassium chloride as well as water. Now students, we will see how dehydrohalogenation takes place. Right students, we will make the molecule of vicinal dihalide. For example, we have this molecule which has two chlorine atoms on adjacent carbon atoms, and here we have hydrogen atoms which are attached to make each carbon tetravalent. Usually this reaction is proceeded in the presence of alcoholic potassium hydroxide. It means we dissolve potassium hydroxide in alcohol. alcohol. Right students, now we will see how reaction takes place. Hydrogen and halogen atom removed from adjacent carbon atom. Chlorine atom from carbon number 1 and hydrogen atom from carbon number 2. This chlorine atom combine with potassium and remove in the form of potassium chloride. This hydrogen combine with this hydroxyl group and remove in the form of water. So we will see what product is formed after the reaction. So after the reaction, here we get the first double bond between two carbon atoms. We get here we get the first double bond between two carbon atoms. Chlorine is attached with this carbon, and here we have the double bond between the carbon atoms. With this carbon, two hydrogen atoms are attached. Beside this, the other compounds which are formed, potassium chloride as well as water. This is the first step of the reaction, students. This is the first step of the reaction. Now we will see the second step of the reaction. Let's see what is the second step of the reaction. In the second step, again we will make the molecule. This is the second step of reaction, students, and here we make the molecule. We have chlorine atom here. With this we have hydrogen, as well as here we have the double bond between the two carbon atoms. Right students, here we make the double bond, and with this carbon we have two hydrogen atoms. Reaction is proceeded in the presence of alcoholic solution of potassium hydroxide. Here we have potassium hydroxide, right students, in the presence of alcohol. Now students, we will see what product is formed after this reaction. Here chlorine atom is removed from, if we do the numbering, this is carbon number 1, this is carbon number 2. Chlorine atom removed from the first carbon. This chlorine atom combined with this potassium atom, and it will remove in the form of potassium chloride. Right students, and from the second carbon, hydrogen atom is removed. This hydrogen atom combined with hydroxyl group, and it will form water. So we will see what product is formed after the reaction. We will see the product. Here we get a triple bond between the two carbon atoms. Similarly, we get potassium chloride as well as water. I hope this is clear to you, students. Now students, we will see the next method for the preparation of alkynes. The method is by the dehalogenation of tetrahalides. Students, here we use two terms, dehalogenation and tetrahalides. We must know what are tetrahalides. Tetra means 4. These are the organic molecules which contains 4 halogen atoms on adjacent carbon atoms. Organic molecules contains 4 halogen atoms on adjacent carbon atoms are known as tetrahalides. Dehalogenation means removal of halogen atoms from adjacent carbon atoms. Removal of halogen atoms from adjacent carbon atoms. Now students, we will understand dehalogenation of tetrahalides with the help of an example. Right students, we will write the reaction here to understand the concept. We will write a tetrahalide molecule. For example, we have we have 1,1,2,2 tetrachloroethane. Here we have chlorine atoms, right students? This is tetrahalide. Now when this tetrahalide is treated with zinc dust means zinc powder, right students? When this tetrahalide is heated with finely divided zinc or zinc in powder form, when it is heated with zinc powder, then hydrogen and halogen atoms, 2 halogen atoms removed from adjacent carbon atoms, right students? From this carbon, one chlorine atom, and from this carbon another chlorine atom. these chlorine atoms removed from adjacent carbon atoms, right students, and as a result of this reaction we get here 1,2-dichloroethene molecule. Let's see what is the structure of ethene, which is formed double bond CH. Here we have chlorine atoms. So this is, if we do the numbering, it is 1, 2, how many chlorine atoms are there? 2. So we use dichloro, 1,2-dichloroethene. This is the first step of the reaction, right students? From tetrahalides we get alkynes in 2 steps. Now students, we will see the second step of the reaction. We will write the second step of the reaction. Again we write the 1,2-dichloroethene molecule, that is HCCl double bond CClH. Now students, we react this molecule with zinc powder, heat 1,2-dichloroethene with zinc dust, right students. Then what will happen? 2 halogen atoms, they removed from adjacent carbon atoms. 2 halogen atoms, they removed from adjacent carbon atoms. So as a result we get the product with a triple bond. The product which is formed is ethyne, HC triple bond CH. Beside this product we get zinc chloride. Similarly, beside the product we get zinc chloride here, as well as here we also get zinc chloride. So in this way we get ethyne molecule from tetrahalides in 2 steps. Right students, I hope this reaction is clear to you students.